Which part you are talking about? TM or before the assignment? We already had a lot of discussion on the TM part. I don't know about this practical subjective assignment. This is different from which we discuss in the class, or is it the same? So I need to check about this practical subjective assignment. I haven't checked about it. I only checked for the weekly assignments and quizzes part. If you have any doubt, please let me know. Otherwise, I guess, in each and every lecture, we have not directly focused on the question answers, but firstly, we have discussed about the theory part and then only we went to the numerical answer type questions. So you can answer the subjective and objective both only, I guess. Exam pattern, actually, I don't know. Maybe you can see the previous year question papers or you can consult the other TA. He is involved in the exam preparation. I'm not involved. He'll be having his class tomorrow, I guess, on Sunday. So maybe you can ask these questions to him about the exam pattern. Okay. Any other doubt to anyone? If you don't have any doubt, can you please lower down your hand, Anamika? You're welcome. We just are here to explain the things. I guess from in each and every lecture we have explained everything. Then only we went to the quiz and questions. So you will be able to answer all the subjective questions as well. Any other general comment from any of you? Any other doubt? You can ask. This is our last lecture for this course of material characterization. I don't know about the exam pattern of the final exam. The other TA, Rohit, is involved in this. His class will be tomorrow, I guess. So you can ask him, or you can see the previous year questions. I don't know about the exam pattern. Sorry for this. But I guess you'll be able to answer as we have been trying to explain each and everything from last 12 weeks, all the material characterization course. Okay. Any other doubt? Any other comments? A lot of students have joined this today's last class. Happy to see all of you. If I may ask, when are you having your final exam for this course? Has the date been decided? Has the date for final exam been decided? 21st April. Okay. Sonia, can you please mute yourself? If you don't have any further comments or doubts, so a lot of you have joined, so let's start today's lecture. I hope my screen is visible and I'm audible to you guys. So this is the last lecture, lecture 12. Let me go in the slide sharing mode. Yeah. So this is lecture 12 of material characterization course given by Professor S. Sankaran from IIT Madras. And this is me, Dorothy Sachdeva, your TA, and I am currently doing my PhD from MRC department at Indian Institute of Science. So in this whole course, we have talked about a lot of characterizations, starting from the optical and went from optical, and there were different techniques for optical. Then we went to SEM part. There are also different electrons like your secondary electron, backscattered electron, Auger electrons, characteristic X-rays. So all these electrons can give different type of information about your sample. And then we went to the TEM part, where and also we went to the a little bit about the STEM, where can I have a blank slide? Hmm. So starting from your optical, we went to your SEM, then we went to TM, then we had a little bit about your STEM. So in STEM, your firstly, so as you go from here, your resolution will increase. That means you'll be able to see much smaller objects, much smaller. Like in STEM, you can have nowadays atomic resolution images. If you are having your atomic resolution images in TM, that one will not be known as called as atomic resolution, because in TM it is not the atomic columns. So in TM, if you are getting an image like this, in STEM, you can say that this will be your atom column. Each one will be your atom column. But if you are getting the similar kind of image in your TEM, then you can't say that this is your atomic resolution, because in TM you are getting your interference pattern. And in interference pattern, you can get, if you are in not in zone, then you will get your high resolution images where you will get your interference fringes in one direction. But if you are in exact zone axis, which we discussed like this. So if your center is in an exact zone axis condition, then also you will get your images like this. But this is your interference pattern, not your atomic columns. So in TM you cannot get these, you will get only interference pattern. But in STEM you can have your STEM also. There are always aberrations are always there in your instrument, and you can correct those aberrations. There are various kind of aberrations which we talked about, starting from SEM only or from optical only, like spherical, chromatic aberration, diffraction limitation, resolution limit. All these things contribute to your aberrations. That's why your resolutions went bad. So in STEM, you can have your probe corrected STEM or image corrected. So there are two type of correctors which can be used in STEM to improve the resolution quality of your image. So these are just the physical parts which are put in your SCMT STEM column is like this. Then these are parts which are put in between the column itself to get much better resolution as compared to the normal stem without any aberration correctors. And then we discussed about the diffractions also and how the X-rays also in between we discussed about the X-rays as well and how we can analyze the diffraction, how diffraction will take place and how we can relate, how much more information we can obtain from X-ray as compared to the TM as com in TM as compared to your X-ray. So that will depend upon your evolved sphere, your incoming radiation electron energy of your incoming electron. So all these things we have discussed. Today we'll discuss a little bit about the sample preparation techniques. Basically, sample preparation for TM because in TM your electron beam, if suppose this is your sample, your electron beam needs to transmit through the sample to get the information. So the electrons need to transmit the sample. That means your specimen should be thin enough so that it can allow the electron beam to pass through. So thinning itself can be done in various different ways. And if you have directly prepared it, nanomaterials, so nanomaterials are thin, it's thin itself only. So you don't need to do further thinning of these nanomaterials. You can directly place these nanomaterials, or you can have this drop casting technique, where I'll show you in the next slide, like this one. So this is basically, these are basically some of the example of the grids where suppose this is your sample holder. There is a small place to have your grids placed over there, and only this part will go in the vacuum column of your TEM. So you please don't touch this part with your bare hands. You should not touch any of the part with your bare hands, but this part especially goes into the column, vacuum column. So this should be very clean. Otherwise it will damage your column and it will create problem. So these small grids are placed at this position in your sample holder. So for the case of the nanomaterials, you directly dropcast these nanomaterials on your grid itself, and these grids have different kind of meshes in them, and when you dropcast your sample, suppose you have a nanoparticle and you dropcast it here, then it is being placed randomly on the grid. It might overlap also, so you need to dilute it and prepare a very dilute solution of your sample. Solution of your sample and dropcast it on your grid, and then after drying for 1 day, then you can use this grid directly into your TM holder. So basically these are different kind of grids which are being available in the market. Also there is this mechanical punch which is used for the thinning of the sheets which are for the ductile materials. Sheet sample is placed in the punch as indicated like this at this place. and the handle on the right hand side is pushed down, ejecting a 3 mm diameter disc suitable for thinning. So this is just the initial step. A variety of specimen supported grids of different mesh and shape are shown in this. Also you can have these are complete mesh kind of things. Also you can have this, and there will be some carbon coating on all of the surface so that your sample should not fall and all. So when your sample is very big, then you can use your lacy carbon grids also. Lacy carbon grids have this hollowness in between them. So this is complete vacuum region. So you can directly place your, so if your particle is directly placed here, so no carbon coating will interfere in this case, and you can directly see your nanoparticle in this case. So initially you have your dimpling apparatus. A dimpling apparatus, what does this do? So if you have a sample like this, it will create a dimple. Suppose this is basically it is used before the thinning of your specimen, because before thinning, if your sample is very thick, then you need to do dimpling, and after this dimpling your sample will be thin enough so that you can do other kind of final thinnings like your iron polishing and all you can do after this dimpling. So firstly you have this punched out disc, and then you will grind this to make it very small. So when you have only, after grinding you have only this much amount of your sample, thick thickness of your sample is around this much, then you can use your grinding wheel of your dimpler to have a dimple in your sample itself. So after this dimpling, you can have your iron beams, and your iron beam can tear it apart, and you can have in the end at this region, you can have a very thin specimen here. Initially it was this much thick, and then after dimpling you created a dimple, and after the iron beam you just removed the thickness and it was very thin. So basically you are having a grinding wheel in this dimpling instrument, which is rotated over the specimen to create a dimple. So this is the rotating axis. So that means it rotates in this direction. So in this case, you just need to place your sample over the specimen mount, and then this grinding wheel will grind itself by rotating it in the perpendicular direction, and it will create a dimple in your specimen like shown in this case. This case. Okay. Then this was just the pre-thinning thing, this dimpling, if you have a very thick sample. Then these are some of the techniques which are used for final thinning of your sample, like this electropolishing. Electropolishing thins your sample, and also it will create a very smooth, sorry, it will thin your sample, and also it will make very smooth surface of your sample. Suppose if you want to do some other technique like WDS instead of EDS. We discussed about this EDS and WDS in the previous classes. So if you want to do WDS, WDS is taken from a specific region. If this is your sample, this specific region, if it is flat enough and not bumpy, then you will get a much good data as compared to the bumpy sample. So when you want to do WDS also, you need, if you are having a electropolished sample, then it will give very good result as compared to the rough sample. So this is used only for the electrically conducting materials. So no mechanical damage is there, but the surface chemistry can change because you are using the electropolishing thing. Electropolishing curve shows the increase in current between the cathode as the applied voltage is increased. Polishing occurs at the plateau in this region, shown by this yellow curve. Etching at low voltages and pitting at high voltages. The ideal conditions for obtaining a polished surface requires the formation of a viscous film between the electrolyte and the specimen. And also we have this jet polishing, where you have your sample holder in between, and from both the sides your jet is flows at a very high pressure, and then it thins your sample which is present in between these two jets. So these are just the pumps, and from there a very high pressure is fallen on these samples to make it a thin sample. So in the jet polishing, the disc must be rapidly extracted from the electrolyte and washed in the solvent to remove any residual electrolyte which may etch the surface. Undoubtedly, you get better at electropolishing with practice, but reproducing the correct condition of temperature, electrolyte solution, chemistry, stirring rate, applied voltage, polishing current, etc., can only be achieved through trial and error. So you won't get your same result every time. You need to be much more, you need to do much more practice to get a good hand at this jet polishing. And then we have this ion milling, where if you have a sample like this and you have a amorphous layer and you simply need to remove this amorphous layer. So first your ion gun will be removing this top layer, and then you will have this clear sample. So ion milling is basically your ions will be bombarded on from the top, the inert ions, and then you can get a clear sample, or if you want to thin, then you can thin it as much as you want. So this argon gas bleeds into an ionization chamber where a potential up to 6 kiloelectron volts create a beam of argon ions that impinge on a rotating specimen. The whole apparatus is under vacuum. The specimen may be cooled to the liquid nitrogen temperature, and perforation is detected by the penetration of ions through the specimen. So you can have your rotating disc where you can place your specimen, and then these ion guns are bombarded on this surface, and this whole instrument is under vacuum and in the liquid nitrogen temperature. So then you can thin your specimen using this ion milling technique. So if you want to have your cross-section sample preparation, then your sample you can either you use one is the FIB technique, where you use your ion beams ion beam to just suppose this is your sample, this is your grid, and your sample is present here, and if you want to look at the cross section of this, you will just cut this like this using your ion beams. Ion beams will be bombarded on it, and then you will be, after looking at this, then you will be having your specimen like this with your base like this. So this is your specimen. Then you need to look at this side. So then you have your special TM grids, which are known as half TM grids, which are either MIM or which are 4I, 4 teeth. So you can thin this sample, and then you can place it in here, and then in the TM you can look at the cross section of this. So this FIB technique can be used for the cross sectioning of your sample. Or you can simply, the sample is cut into thin slices normal to the interface, which are glued together between the spacers, which could be silicon. So this grid is used over here. Firstly, you cut your specimen into thin slices like this, and then these are glued together. So these are your spacers. So in between them you have your thin slices of your specimen, and then these are placed in the grid, this grid itself, and then the club sandwich is then itself glued to the grid and iron milled to perforation. So this glued one is then this sorry, not glued one. So when the thin slices of this sample is placed in between the spacers, then that combination is glued onto their TM grid, and then it is iron milled to have a until the thin specimen is formed. This is just the detail of the electropolishing method. Just a sheet of metal which you want to thin around 1 centimeter is lacquered around the edges and made the anode of an electrolytic cell. The progress during thinning, the initial perforation usually occurs at the top of the sheet at this side, like this is shown in here. The lacquer used to cover the initial perforation, and the sheet is rotated 180-degree then to have your thinning at the bottom part itself, and then the thinning continues to ensure that the final thinning occur near the center of the sheet. The final, if the final edges is smooth rather than jagged, it is probably too thick. So basically, when you have your sample sheet like this, it starts thinning from the top, and then you rotate it 180-degree, and then it started again thinning from the top, and then thinning occur near the center of this sheet at this position. So if the final edge is smooth rather than jagged, like in this case, then it's probably too thick. So you need to thin it using this electropolishing method. And then you have this ultra microtomy, where you place your sample over here and you use this knife. This hole is knife to cut your sample into thin slices. So your sample is first embedded into the epoxy or some other medium, or the whole sample is clamped and move across the knife edge. Suppose this is your complete knife, and your sample is like this. So this sample is cut through this knife in very thin slices like this. The thin flakes float onto water or an appropriate inert medium from where they are passed on to the other TM grids. So basically, there is a continuous flow of water and your sample is thinned using this knife itself. And also you have these plasma cleaners. These can also be used for the final cleaning where you need to remove your organic impurities or other impurities which are present in your sample due to the environmental contamination. So this plasma consists of energetic electrons and ions that bombarded the surface and break the CH bonds with short duration of exposure. The surface, if the specimen itself is unaffected. The hydrocarbon gradually reduces in molecular weight and are pumped out. So if you are having some organic moieties or some hydrocarbons due to the reaction with the environment itself, then they will be cleared out in this plasma cleaning. Oxygen, nitrogen, argon are the most commonly used gases. You can have hydrogen also, but it will not be complete pure hydrogen. The hydrocarbon, or you can have use some mixture of your gases as well during this plasma cleaning. So basically it have an instrument like this where you can directly place your sample holder in between and then you will have your passing of your plasma of either of these gases, oxygen, nitrogen or argon, and then that gas will remove some hydrocarbons or some will break the CH bonds. The hydrocarbons gradually reduced in molecular weight and pumped away in the vacuum of the cleaner. Oxygen, nitrogen, argon are the most commonly used gases, but you can have the plasma cleaners using this each of the gas or the multiple gases, or you can have other gases as well like hydrogen and all. So is there any doubt in this sample preparation techniques, or we can start this week's assignment? Any doubt to anyone? Any comments? This you'll get much more insight when you will directly do the sample preparation. There won't be any learning part for this until and unless you do it yourself only. So is there any doubt, any comments in any of the theory? If no, then we'll start the practice assignment of this week 12. If you have any doubt, please write it in the comment section or raise your hand. So the first question says, which among the following is a beam sensitive material? Beam sensitive material means the material which will get damaged when the electron beam falls on the specimen. So the option says metals, composites, polymers or ceramics. Any guesses from anyone? I guess we all can participate in today's question answers. Sonia says B, composites. Any other answer? Any other suggestion? Any other? Soumya Rajesh says option C, which are polymers. Yes, polymer is the correct answer in this case. Composites are just the composite of different metals that will be very stable in your electron beam until and unless they are very sensitive. But polymers are very sensitive to your electron beam. they will easily get distorted. So option C is the correct answer for this question. Polymers. The next question says the diaphragm or the aperture discs are made up of what? Aluminium, platinum, or titanium? Remember, in your TM column, you can have your objective aperture. Firstly, you have condenser aperture, SAD aperture. So in this apertures, you can have different sizes. So in SAD, I told you you can have different sizes. Suppose this, this, and this. So this is just are the physical holes which are made in certain kind of metal, and then you can have any of these hole in this. Suppose this is your optic axis. Suppose if this is your column, this is your optic axis. So if you are adding any of these aperture with the specific size which you want for your technique, then you need to align that size along this optic axis. Suppose you have selected this number 2, then you will align properly with this optic axis. So these are just the physical holes which are present in the metal. So the metal which is used for the aperture are is which metal? Any guesses? That should be inert, should not react much because it's present in very high vacuum condition. Platinum. Yes, you are completely correct. It will be platinum because it is very inert. It won't react much. So it's safe to have this. The next question says to record microstructural images, both objective and SAD apertures are required. You know the purpose of your objective aperture and purpose of your SAD aperture. Objective aperture, I'll write OA. Objective aperture will be used when you are doing your imaging of your sample, and your SAD aperture or SAD aperture is used when you are doing your diffraction. When you are obtaining diffraction, diffraction is your in your reciprocal lattice space. So to record microstructural images, both objective and SAD apertures are required. Is this statement true or false? Yes, this statement is completely false because we can't use both the apertures at a single time. For imaging, you need to have only your objective, and when you are obtaining your diffraction pattern, then you need to have your SAD apertures. Will your this is just a general question. So if you are having your, I'll just erase this. So if you are having your TM column, and I guess you most of you have seen the video which sir has shown, where he has and one of the instructor have shown the whole column and how the TM works and complete instrument part. So can anyone tell part A, will the objective aperture will be above the SAD aperture, or option B, the SAD aperture is above the objective aperture? This is my general question. Can anybody answer it? From going from top to bottom of your column, TM column, firstly you will have your objective aperture and then SAD aperture, Or option B, you will have your SAD aperture and then your objective aperture. Silva Murugan says option B. Any other comments? Any other answers? Just in this, to answer this question, please remember your ray diagram of your TEM, where you starting from the electron gun, coming to the condenser lenses, objective lenses, and then your specimen and everything. Any other comments from anyone? Option A is the correct. First objective aperture is there in the column and then SAD aperture. You are saying it opposite, Selva Murugan. Just please go and see that video where they have completely shown the TM column. So initially, the the parameters which you as a user can change, you can have your condenser lenses can be condenser lens 1, condenser lens 2, condenser lens 3. So generally the instrument have two condenser lenses. So if the instrument is having two condenser lenses, then you can change the strength of condenser lens 2. Then you will have then you will have your objective lens and then objective aperture and then you will have your SAD aperture. Okay, you can change the parameters of all these three, the different apertures, and then you need to align all this. Okay, the next question says a method can be used for the preparation of polymer or soft TM samples. So for polymers or for preparation of soft TM samples, jet polishing have a very high pressure of jet from both the sides that will destroy your soft sample, so that can't be used. Ion meaning also you have a high intensity of ion beams which are falling on your specimen, so this that can't be used. So this ultramicrotomy can be used, which we discussed lastly, where you have your simply your knife is placed at this position and then you have your sample and then what continuous flow is there and then thin specimens are cut using this knife like this. So option C is the correct answer in this case, that ultramicrotomy method can be used for the preparation of polymeric or soft TM samples. Okay, the next question says when using microtome for sectioning, what is the purpose of using glass knife? So this glass knife is used for what purpose? To trim the cutting edge of the sample blocks so as to make it flat, only the cutting edge of the sample, to section the specimen into thin slices, or to hold the sample blocks, or it allows us to monitor the process of sectioning. I need the answer from you guys. This we have discussed in the today's class, so any one of you can answer. Yes, option B. Soumya says option B, Nitin says option B. To section the specimen into thin slices. Yes, this knife is used for this purpose only. This is a glass knife. Okay, then we'll go to the quiz of this week. So this is the quiz for this week 12, where first question says, in TEM, a higher spot size of the beam indicates dash FWHM. Lower, higher, or none of the above. So if you are having a higher spot size, this is your spot size, smaller spot size, and this is your higher spot size. So if you are having your higher spot size, your FWHM of the beam will also be higher. Okay. So option B is the correct answer for this question. The next question says, which of the following statement is or are true? The diffraction pattern is not formed on dash. Diffraction pattern. Remember which we discussed when we discussed the ray diagram, that the diffraction pattern forms on the back focal plane of the objective lens, and your image forms on the image plane of your objective lens. So the options of these questions, the options in this question are very confusing. So there is some misprinting in the 2 and 1. So diffraction pattern is not formed on the front focal plane of the condenser lens. This statement is correct for this question, not formed. Just remember this, not formed. The back focal plane of the objective lens, there the diffraction pattern is formed. So according to this note, this statement will be incorrect. The image plane of the objective lens will also be the correct statement according to this question. So according to me, statement 1 and statement 3 are correct answer. There is some misprinting error according to me. Okay. Because this all we have studied, the diffraction pattern will form on the back focal plane and image will form on the image plane. The next question says, question number 3, the following statement is true or false? So the statement is, the main purpose of cutting extremely thin slices of sample is for better observation of intracellular components instead of extracellular components. This statement is true or false? We are thinning the sample so much that for the better observation of intracellular components instead of the extracellular component. This statement is completely true. Okay, so option A will be the correct answer. The next question says, the following statement is true or false? If the interplanar spacing in real space is D, the interplanar spacing in reciprocal space will be 1 by D. You all need to answer this question. I guess we have discussed a lot about this real space and reciprocal space. Reciprocal space basically is your diffraction pattern, right? You obtain this diffraction pattern on your screen. This reciprocal space is 3D. Sharmila, can you please mute yours? Yeah. You can comment or you can raise your hand if you are having any doubt. Otherwise, there is a lot of echo between your voice and my voice. Yes, option A true. Okay, Rajesh and Soumya says option A, which is true. If the interplanar spacing in real space is D, the interplanar spacing in reciprocal space will be 1 by D. Yes, this statement is completely true because in reciprocal space we obtain these diffraction patterns where we have your diffraction patterns like this. Suppose this is your direct spot. then the distance between the direct spot and the diffracted spot will be given by 1 by d, and this will be 1 by d. This will be d1, this will be d2. So this is another family of plane, this is another family of plane, and this is 1 by d3. This is another family of plane. So in real space, the spacing was d, and in reciprocal space, it's 1 by d. So this statement is true. The next question says, the following statement is true or false? The statement is, the arrangement of the apparatus, the arrangement of apertures vertically from top to bottom are, this you can tell. Now, since we discussed, I didn't know this question will be coming up, but we have already discussed the answer of this question in the last. Selva Murugan is saying it is true. How? Can you please explain? Firstly, you get the objective aperture and then you get the condenser aperture. Please see all the arrangement. It says, firstly, you will have your objective aperture, and then you will have your condenser aperture, and then SAD aperture. We discussed about the objective SAD, and also I told you about the condenser as well. So, firstly, which aperture will come? Objective or condenser? Any other answer from anyone? Is this statement true or false? Soumya says false. Selva Morgan says true. How? Any other answer? Anyone else? We discussed in today's class only, no? The previous questions only. Anyone else? Till now, there is 50-50 vote for true and false. Let's see where the majority goes. Anyone else? Please reply. Nitin says false. So now the majority is false. So this statement is false. We discussed, no? Silva Murugan, did you remember that we discussed that firstly you will have your condenser, then you will have your objective. Remember your ray diagram of your TM. Starting from gun, you will have your condenser lens, then you will have your objective lens, then you will have your specimen. Remember? After this, you will have your SAD aperture. Okay. So he also agrees now. Now full majority wins. So this statement is false. So the correct order will be, this should be opposite. So firstly your condenser aperture will come, followed by your objective aperture and your SAD aperture. Okay. The next question says, question number 6, the following statement is true or false. The deviation parameter is, this deviation parameter we discussed in the last class. A lot of about the deviation parameter in the last class. Yes. So this deviation parameter, if you all remember, you will be able to answer this question. So the deviation parameter S is nothing but the distance of the evolved sphere passing through the diffraction spot that is slightly away from the Bragg position and the exact Bragg position. So Bragg position is what? where the evolved sphere touches your reciprocal lattice point. Suppose this is your origin and this is your reciprocal lattice point. Suppose if this is your reciprocal lattice point, I'll draw it with different color. Sorry. This is your evolved sphere. This one is also showing your, this point is also showing your diffracted spot, but according to the Bragg's condition, only the spots which are touching the evolved sphere like this one should only be diffracted and should follow the Bragg's condition. This is away from Bragg condition, this spot, but then also we are able to see a spot, a diffracted spot, which is following the Bragg's condition at this point. Because if the material is in nanometer regime, then you will be having your railroads which will be elongated in the perpendicular direction in which they are in very thin. So this will be not what happened to this? Why it's not moving? So instead of the spots, you will be having your railroads which will be elongated in this direction. So even if your evolved sphere is passing from this, you will get a diffracted spot, and this deviation from your exact Bragg position to this Bragg position which is slightly away. So this is what your deviation parameter S. So the statement says the deviation parameter S is nothing but the distance of the evolved sphere, this evolved sphere, passing through a diffraction spot that is slightly away from back position and exact Bragg position. So this is the deviation parameter. So this statement is true. Okay, remember we discussed in the last class, no, about this deviation parameter S. Any doubt? If no, then let's come to the next question, which says fill in the blanks. Projection chamber and camera requires the vacuum of the order of what? So this they are talking about the camera and the projection chamber. So this requires a vacuum of 10 raised to power minus 3 to 10 raised to power minus 4 millibars. So option D is the correct answer for this question. Okay. So the next question says the following statement is true or false. Dash technique can be combined with TM to analyze chemical composition of sample. This, I guess, you all can tell. The chemical composition is told by in which characterization technique? Atomic force microscopy (AFM), Fourier transform infrared spectroscopy (FTIR), or statement 3, energy dispersive X-ray spectroscopy (EDS). So from these three techniques, which technique can be combined with TM to analyze the chemical composition of your sample? People say option C, EDS. Yes, all the three of you says option C, EDS. So this EDS, how does this EDS work, and how does different elements will tell you about their properties that different element is present. So depending upon the energy which is released, so that will depend upon the shell from which the electron is being emitted, and different atoms will have different shells, different energy. So according to this, you can tell which element is present. So each and every element have their unique EDS spectra. So this can be combined with TM to analyze the chemical composition of sample. So option C is the correct answer. Only third statement is correct. Okay. I'm happy that you all are trying to answer the question and you are mostly correct only. The next question says, question number 9, which of the following electron detectors is commonly used in TM? In TM, basically you have your camera at the bottom. So which kind of camera or which electron detectors are used in TM? Photomultiplier tubes, CCD charged couple device, scintillators or Faraday cup. So generally this you have must have been seen in the SIR's experimental section where he practically showed you the TM. There also they told that your yes, Selva Murugan, you are correct. The option B is the option B is the correct answer. CCD is generally used to detect the electrons in the TM. This is charged couple device. Next, all other can also be used, but generally CCD is used. The next question says, which of the following is an advantage of cryo-TM? Cryo, do you know what does it mean? And what is the advantage of this cryo-TM? High resolution, faster imaging, no sample preparation required, or reduced beam damage to samples. Cryo is done at a very lower temperature, basically cooling. Yes, you are correct, Selva Murugan. This is used for the cooling of your sample. So the advantage of this cryo TM will be a higher resolution, faster imaging, no sample preparation or reduction in beam damage to sample. Any comments or any uh, idea about the answer of this question? Soumya says option D. Rajesh says option D. Selva Murugan also says option D. Yes, the reduction in beam damages to the sample when you are using your cryo TM. So option D will be the correct answer. So is there any doubt or any comments in the quiz part of this week? If no, then I have certain few questions which we can discuss, and these questions will help you, this especially the first one, to analyze your diffraction pattern and all. In the meantime, I'll just give a 1 minute time gap where you can have any doubts or any comments in the previous quiz. This I don't know about the final exam. You can ask in the tomorrow's class. He is preparing your question answer, I guess. Yes, Sharmila, please tell. You can just write it on your copy and then you can scan it and make a PDF and then you can upload, no? Yeah, yeah. You can discuss among the other students if they have submitted. remove the. Can anybody please help her? I don't know about this assignment. Can anybody of you help her? Did any of you submitted the assignment? Sharmila, according to me, you need to write down. Someone has uh, someone has commented in the comment section, Selva Murugan only, that if you want to change the answer, you need to remove the older version. Just that only. Otherwise, you need to write your answers and then scan them and then upload it. Uh, Actually, can you please mute yourself? I'll answer. There's a lot of echo. Yeah, actually, all of you are asking me about the structure of your final exam only, the pattern of that. I don't know. Maybe you can ask Rohit in the next tomorrow's TA ship where he might be preparing your exam or he is helping. I'm not involved in the final exam. So basically, you can either search on the NPTEL about the previous year question papers or you can ask him directly. I'm not involved in the preparation. Sorry for that part. If you have any doubt related to the theory or anything, please let me know. But about the exam pattern, I'm really sorry to you guys. I don't know how the questions will come. Sharmila, do you have any other doubt? Can you please lower down your hand? Sharmila D. If you have any doubt, please comment. Otherwise, please lower down your hand. Okay. Okay. Abhishek Sahu is saying pattern is suddenly changed. Previously it was objective type and now it has been changed to subjective or something like that. Okay, then I don't know. I'm not involved in your final exam pattern. But if you have any doubt, you can ask tomorrow. He might be able to help you guys. I'm really sorry from my side. If there is not any no further doubt, can we discuss certain few questions which will help you guys to analyze the diffraction patterns? If no further doubts or comments, let me discuss this question. Let me zoom it in. this part. So basically you have a crystal structure of the sample which is examined in TM. So it is a FCC type. So just remember this FCC. The diffraction pattern obtained from the sample is given below. This one is complete. The distance R1 is 165.5 and distance R2 is 74. Both are in arbitrary unit. The angle between R1 and R2 vectors correspond to 90 degree. Hint: the allowed reflections in FCC are family of all the 111, 200, 220, 311, 222, 400, 420, 422, etc. So basically, you have this diffraction pattern, and let me have a blank slide over here. That will be much more helpful. So basically, you have your FCC system, and you remember that in your FCC system, what is the condition, structure condition for the certain diffraction to be allowed or not, planes reflection? It says HKL should be either all odd or all even. So according to this, 100 will not be possible, 110 also will not be possible. So the possible planes will be for your FCC system. Possible planes will be 111, 200, 311, then with increasing despacing 222, 400, then you will have your 420, then you will have your 422, right? So this is your increasing order of your despacing for your FCC system. What does your question says? You need to find out the zone axis of the given diffraction pattern, and zone axis is given in square bracket that is used for the direction purpose. And then in the second question, you need to tell about the plane of the spot A, that which plane it corresponds. And there are four options for the each of these. So basically, your R1 distance is 165.5. This is 165.5, and this is, let me erase it. And this R2 distance is 74, and this angle is 90 degree. Okay. So basically you are having these four options for your zone axis. So firstly we'll write 210 zone axis. So if you are having this 210 zone axis, so remember your Weiss zone law to calculate the zone axis, which says that your zone axis will be UVW for HKL planes when it will follow HU plus KV plus LW equal to 0. Okay. So for this zone axis, the zone axis is UVW. This is your zone axis. So when you are having this 210, then the dot product of zone axis to the plane should be 0. Then only they'll be perpendicular. Suppose if you are having your planes like this, so zone axis is what? A perpendicular, which is either inside of this screen or outside of the screen. So this direction, which is perpendicular to this plane of paper, that will be known as your zone axis. And the dot product of your zone axis to either of the to any of the plane in this zone axis will be 0. So for 210, dot product with 111, will it be 0? No. So this plane will not be allowed over here in this zone. And this 200, this will be allowed. This will be 0. In which form? 002. So if it is a cubic system, then 200, 002 are both in the same thing, both will have similar d spacing. So this 210 zone axis can have 002 plane in between in that zone axis. So it will have a 0 value. 311 it won't have. 222 also it won't have. 422 is similar to 200 only. Similarly 004 in this case it will be 0. But not here, not here. So this is only one family of your HKL. So you need to have two R1 and R2. So this zone axis won't is not allowed. Is not answer of this question. Next is bar 210. So in bar 210, when you do dot product of bar 210 with 111, then it will, sorry, it is not 0. In this case, it will be 0 only in 002. In this case, it won't be possible to be 0 in any of the, either in 311 or 131 or 113. Okay. In this case also it won't be 0. It will be similar like the previous one only. So only one plane is there. Next one, option C was 220. So in this 220, this can't be 0 in any case. This will be 0 in 020 and 002. Both are one and the same thing only. This can't be 0. This can't be 0. This is similar to this one only, so it will be 0. This also can't be 0. Sorry. And this also can't be 0. And the last one is 1 bar to 0. So with this 1 bar to 0, the dot product can't be 0. In this case, it will be 0 with 002, and with this 311, it won't be 0. 222, it won't be 0. This 0 with 004, it will be 0. And with 420, it will be 0, because the dot product of 4 into 1 will be 4 HKL 420 UVW 1 bar to 0. So 4 into 1 is 4 plus 2 into minus 2 plus 0 into 0. So this is 4 minus 4, this is 0. So this is 0 and this will not be 0. So here are two possible planes. One will be 002, another will be 420. So this zone axis, option D is the correct answer for this case, and the possible planes will be your 420 and 002. For your zone axis is generally written on the right hand side in the square bracket. So they are next question says what is the A plane? So plane A will be either 002 or 420. So basically you know that the 002 have a lower D value. This has a low D value as compared to 420. So this is in reciprocal space. So in reciprocal space, this will be having higher 1 by d value, because here the distance is in 1 by d, which we discussed in the previous question. So this 165.5 is basically your 1 by d. So 1 by d will be larger for 002. So this point B will be 002 and point A with smaller 1 by d, that means larger d. So it will, point A will be 420. Right or wrong? This statement is itself not correct. I guess you are not paying any attention. This will not have lower d value. D value, what is the formula for the cubic system of d value? D is equal to A under root of h square plus k square plus L square. So for 002, your d value will be larger. Okay, so this is incorrect. None of you corrected me over here. Are you all paying attention? So this is having a larger d value. So if this is a larger d value as compared to 420, so larger d value means in reciprocal lattice it will be smaller. So this point A will be 002 and point B will be 420. Okay. So according to this, option A, that is point spot A will be 002 will be the correct answer. You all know, no, this formula D is equal to A divided by under root of h square plus k square plus L square. So 002 will have a larger D value as compared to this 420. Also, you can check this, that since I'll add one more. Yeah. Since you all know that your R1 is to R2 value according to the given points are 165.5 divided by the 74 distance. So if you divide these two, I have already divided it, it comes around 2.236. And when you look at the planes, so this R1 by R2 in reciprocal space is reciprocal, so it will be become D2 by D1, and according to this it will become h square h, h square plus k square plus L square under root L square, and for D1 it will become A divided by h square plus k square plus L square whole under root. So it will be basically what? 420 for this one and 002 for other. So 420, 4 square plus 2 square plus 0 square whole under root. 1 will cancel out. And the next will be 0 square plus 0 square plus 2 square. So this R1 divided by R2 your will become 16 plus 4 divided by 4 under root under root. So this will be 20 divided by 4 whole under root. This will be under root 5 and under root 5 value is 2.236. So this also confirms that your planes are 420 and 002 according to this given R values, which are 165.5 and 74. So this also confirms. And also you can confirm them using your cos theta value. This is clear to you? You can confirm this using this, or I'll add one more slide. This will be 2 square. This will come out to be 2.236. These are similar. So this confirms that your planes are this. Also, you know that the angle between these two planes is given by cos theta is equal to h1 h2 plus k1 k2 plus l1 l2 divided by under root of h1 square plus k1 square plus l1 square whole under root into h2 square plus k2 square plus l2 square whole under root. So when you are taking these two planes, so just put the values of h1, h2, k1, k2 and l1 and 2 from this 4 to 0 and 0, 0 to. So cos theta will become 0 only. 4 into 0, 0, 2 into 0 and 0, 0 into 2 will be 0. So according to this, theta will be your 90 degree, which was given in the question, that the angle between r1 and r2 vector is 90 degree. So according to this, the zone axis is 0 bar to 0 and the plane of spot A will be 0, 0, 2. And we have confirmed it using different techniques. This is clear to everyone? Any doubts? This is how you'll be analyzing your diffraction patterns. Is there any doubt in this question? This question is clear to you, then you will be able to do your diffraction pattern analysis. And since in last classes we have done the diffraction pattern analysis for the standard samples like BCC and FCC and all, for the standard zone axis like 111 family or 001 family for hexagonal system as well as for the cubic systems. So then I'll move to the next question if there is no doubt from any of you. So the next question says, which of the following is a pre-thinning technique? Remember this pre-thinning technique and not the final thinning during the TM sample preparation. This any one of you can answer. This we discussed in today's class. Either iron milling, jet polishing, dimpling or ultramicrotomy. Pre-thinning technique, before thinning. Any comments from you guys? Soumya says option C, dimpling. Yes, you are completely correct. This means you are paying attention in today's class. We discussed in the initial hours, initial minutes only. This dimpling will be used as a pre-thinning technique to thin your very thick sample with the help of a dimpler like this. Okay. The last question says the camera constant is given by. You remember in the reciprocal lattice, this camera constant is generally used. There was one camera length equation which says RD is equal to, sorry, I'm saying anything, I'm writing something, which says RD is equal to lambda L, where R is your distance between your two spots. D is basically your D spacing. Lambda is your wavelength which you are using, and L is your camera length. So basically, your camera length constant is given by what? RD, lambda L, LR, or D? It is given by this lambda L. So L lambda, option B will be the correct answer. Okay, your camera length is lambda L. With this, I have completed this today's class. If you have any doubts, any comments on any of the part, please let me know. Otherwise, for the pattern of your final exam, you can ask Rohit in tomorrow's class. He might be able to help you guys with this. I'll also ask him to help you guys with this pattern thing. If there is any comments or any doubts in the theory part, please let me know. I thank all of you to be so patient and listening to me for continuous 1.5 or 2 hours every week. I hope from my side I was able to explain each and everything to you guys, and I hope that you will were able to understand the things much more clearly. I have tried my part best to explain you guys, and I hope that you have received a higher percentage. I thank all of you to please to who were there regularly in my class. If you have any doubts, please let me know. Otherwise, I'll thank all of you for attending my tutorial classes for this material characterization course. If you have any comments or any doubts, you can please raise your hand or type in the comment section. Yes, as usually, I'll share these slides in the same Google Slides link itself around in half an hour or so. And also, I'll upload the recording of today's class on the YouTube. As usual, I'll do this for the today's class as well. And for the all previous classes, the slides have been already uploaded on the Google Slide link. Shega Murugan, you were very regular to our class. Even Sharmila also, you were very regular to our class. If you have any comments on how can I improve or which things you were not able to understand, please let me know. Otherwise, you were actively participating in the question answers as well. And even you asked doubts also in the comment section, I remember. Are you all three there? Do you have any doubts? This assignment question number 2, what is the answer? For the quiz part, there is a misprinting in the answer. Option 1 and 3 are correct for that question, not 2 and 3. Sharmila D and Sharmila Shiva, are you there?